Ok, italiano o inglese? English or Italian? Uh, so, how many don't understand Italian? There is at least and one, so we should do it in English. Uh, is that okay with you? Okay, good. So, maybe can I start asking how many of you work within Internet of Things? You good. And and how many in the educational Internet of Things? You great. So this talks is particularly for you, particularly interesting for you. And well, I'm Simone. I'm a researcher at the Norwegian University of Science and Technology, and I'm going to talk to you about a toolkit that we made for generating idea about the Internet of Things. And so the question we asked ourselves is how we can engage non-experts like kids, makers, artists, and anyone with no formal training in technology or design into participatory, collaboratively design and implement Internet of Things invention. And we've done this because sometimes in this field there is a bit disbalance between technology and problems and needs. So there is a lot of technology there. We can put a chip, an antenna, Bluetooth device in any kind of objects, but then often we don't know what to do with that object. So this research project we're running try to come up with tools and methodology in order to support the early stage of the design process of an invention, a technology invention, into specifically getting people creative and engaged into generating ideas. And so this is basically three elements that make our toolkit. So we have a brainstorming game that is what I'm presenting now, which is called IoT Cards. And then we have a prototyping platform that complements the ideation platform that basically is based on IoT stickers, or stickers with electronics that are used to build the prototype of the ideas that can be generated with the cards. So the main goal of our tool, is basically to engage non-expert into dialogue that could include also different stakeholders, people with different expertise in technology or design, into getting creative and but at the same time keep the ideation grounded on problems or tangible problems for a tangible persona. And we use augmentation as a design strategy. That means that we start from, as much as possible, from everyday objects that are low-tech, and we try to use technology to extend the capability of that object instead of reinventing it from scratch. Why cards? Why we use cards? That's because there is a kind of a long history in literature of using cards as a design medium, as a design tool. That's because if you put people around the table and you give them cards, you put them in a kind of settings where they are more willing to take risks, maybe to speak out in public. And then you can add some gamification feature that allow the design process to be more fun and more engaging for the participant, but also to keep them well. You can, for example, implement some turn-taking process that allows everyone to be part of the process, and it allows to smooth different relationship among the players, for example. And in general, everyone likes to play games, or especially card games and board games. So these settings create some familiarity, it put basically participant at ease. So with our toolkit, we aim to target the first part of the design process. So moving from a problem to an idea and to a design that implements that idea. And please come in, don't be afraid. And so these are the cards, the design cards that we made. And those basically show and try to break down the different elements of the Internet of Things, starting with, of course, things, which are everyday low-tech objects. For example, a chair, a table, a building, or I don't know, any kind of furniture that you can have, you can find in your home or in public space. But then at the other end of the spectrum, the IoT spectrum, you find services which are the opposite of things. So they are immaterial, they are basically digital services, the digital part of the IoT. For example, you can think of services that provide you information about weather, traffic information, APIs that cities are more and more making it public. For example, you can find a service that gives you update information about the pollution in your city and so on. So in between these two type of cards, you find human action, feedback, and sensor that allow you to think how you will interact with the invention, the device that you're designing. On the right far, there are two different decks of cards, missions and criteria, and those are used in the process of getting from a problem to an idea to bring elements of creativity. So missions are mostly provocation that allow people to think out of the box. And to give you an example, one type of mission is, well, there is teleportation. So why you don't think to make a device that allows you to experience different area of the world, or give you, for example, a superpower, or it makes some action more playful or more engaging for the user. So these are kind of example. And at least the last deck of cards we provide are reflection lenses. They are criteria cards. So those allows you to look through the idea that you created and reflect whether the idea address certain criteria that could be, for example, creativity or usefulness or market potential and so on. So these, as you see, there are a lot of cards. There are more than 100 cards, and that's why we provide a board that allow to scaffold the design process and the ideation process for basically the participants of the workshop. And the board has different placeholders that allow, that guides basically participants in group of 4 or 5 to design their own idea and to follow a structure, follow a methodology that is reported in the playbook there. And to be more precise regarding the process that participants go through in our workshop, well, they start from a problem, and a problem that is given as scenario and persona. So scenario is like a story that explains a certain problem. For example, it could be that we have a problem with wastes, so we need to reduce our impact on the environment, so we need to develop some sort of idea, device, or IoT concept that help people to reduce their impact in terms of waste. And then we have personas that are, for example, a group of people, so it could be kids versus elderly, or students, or could be workers, or different part of the population. So you select a problem and a persona for which the problem is relevant, and then you start browsing a different set of cards, so things, services, all the cards that I just shown, and there you basically try to understand whether among those cards there is some objects or some internet service that is useful to solve the problem that you're given. Then using the board, you try to combine those cards in a way that you select triggers and responses. For example, you can select some sort of input, for example, from a sensor card that triggers some action in the system, and then you could have some feedback as a consequence. And a feedback could be like a user interface element, could be display showing some sort of information, or it could be some sort of communication between objects or machines. So it could be that you update some sort of database or you provide information to another object or another system. Then we ask a participant to sketch an idea, basically, one or more ideas that are sort of, that show how the different objects, the concept that you're making addresses the problem. Then we use mission cards to go back actually to step one and to challenge to come up with a better, a more creative way to solve the problem that you're given. And finally, in the last two steps, we use criteria cards to reflect on the outcome of the storyboard. So at this point, you have a kind of defined idea of what your concept is making, what your invention is making, for whom, and how. So the criteria helps you to focus whether, and to more maybe not to focus, but to reflect or to be aware of what are the limitations of your concept. And you can also use criteria in case to drive future iteration. So after you have an idea, you select, for example, feasibility of as a criteria, and then you change your idea in a way that is feasible to produce or is more likely to be possible. That could be prototype, for example. So the tool is generic, so it doesn't provide you specific card for specific domain, but we have extension packs. So we encourage users to create their own cards to focus the idea generation process towards certain domain. So far we have made an extension of the tool towards smart cities. So we have made extra cards when we run the workshop, when we run the ideation towards making idea for smart cities. And those cards includes both things, sensor, and scenarios that are specific for improving the life of people in cities. So we use the cards in workshop with more than 300 users, and we ran a workshop this morning here at the Maker Faire. We had a really great results. We had two groups developing really cool ideas, and together with other than this morning, we run it now probably roughly 20 workshops with users that span between the age of 14 to 60, so quite completely different user groups. So and we've used it in both for educational purposes in schools, and in that case the goal is not to get a product, but to have the student to develop some skills and some ideas that then can be then used as part of courses, for example, for prototyping or to learn how to code or to learn the basics of electronics, for example. And to give you an example, among the many ideas that were developed, we found some concept regarding smart mobility. I can recall many ideas related to helping people with disabilities to, for example, to getting on the bus or moving around the city painlessly. We have idea regarding civil engagement, so basically how citizens can team up to solve the challenge that they face in the city, for example, waste reduction or reduction of traffic, pollution, and so on. Social interaction among elderlies, this is another category that we provide to our participant as a persona. And then lately, humans and sensors, so how we can exploit the information that comes from human to build, to make them kind of sensor in the city, and to allow them to feed this information to others and to other, both humans and system. As I started, my first slides were like how we can engage kids in getting creative, and here I go back to that because in schools we found that these cards have been really useful for fostering both creativity but also to helping kids to learn. And this is because the collaborative nature of the workshop enabled them to learn by doing something, by building a concept, building an idea, talking among each other, rather than learning a concept related to IoT from books. And specifically, the type of learning skills that you can provide or that could be linked with this tool are design thinking skills. The way since that they, as part of the task, as part of the process, the ideation process they go through, kids has to sketch a storyboard, prepare an elevator pitch, allow them to build these sort of competencies that enable them also to be creative and to be designer of new technology also after they're done with our workshop. So together with this, they also learn, or we expect them to learn 20th century soft skills, for example, collaboration, reflection, and creativity that are more and more needed in today's jobs. More on the technical side, because in the first steps of the process, they go through the different card they have to read the different, for example, sensor available, or things, or digital services, internet services. They learn the basics of IoT concepts, so they could learn the difference between input and output, data sources versus sensor, and so on. And since that we have as human action and feedbacks, those cards basically represent elements of user interface, for example, voice interaction, or the fact that I could manipulate an object to trigger some sort of action. They could learn, kids could learn the basics of interaction, the design, and some basic UX concept. And also because they start from a problem and they have to go to get through the process towards a solution, they learn also how to, well, since that they start from the problem, they could also learn something about the problem itself to start, and then they kind of develop skills that allow them to solve problems and so on. And since that we expect that these ideas sooner or later will be turned into prototypes and hopefully in a successful product, in the following, the follow-up to what happens after the workshop, we expect them to learn also to code and to play with electronics. So with this respect, a European project called Yumi Ski Ed has developed a set of material for teachers that allow them to build learning experiences focusing on the card game. And these activities includes some introductory material used to basically make kids familiar to the basics concept of what they need to go through the process, basically. And then it follows with a stage transition from design to prototyping, where a teacher could provide the skills required to build a prototype of the idea. So basic, the basic concept skills and information needed for programming or for making playing with electronics and so on. And then as part of this project, they also provide sort of half-baked programming, half-baked code that the kids can use to implement a prototype of their idea. If you're interested in testing out this tool and using the tool as part of your organization or your school, you can go on our website, tilestoolkit.io, and the cards are available for download for free. They're licensed under Creative Commons, so you can use them for non-commercial purposes. And also, we invite our user to actually come up with new way to use the cards. As I said at the beginning, the cards are quite generic, so the process and the card itself could be specialized for a particular domain, thinking, for example, healthcare or your home automation, as we just heard in the previous talk, and come up with ideas for those domains. So we have a GitHub repository that you can fork, and you can add your own card, you can add your own board and change the process as you like. And if you do, please drop us an email so you can list your extension in our website. So finally, a couple of words on what we're doing now. So our goal is actually to move from the problem to product or prototype. So we are extending this tool with the physical prototyping toolkit that makes use of stickers and some code. And the idea is to implement in hardware and software modules the functionalities that are represented on the card, in a way that if I build an idea that uses a display together with a proximity sensor, together with a air pollution sensor, for example, I have those functionalities available in hardware and software modules out of the box, as without having myself to go and code this functionality multiple times, for example. And these are what we call these IoT stickers. So they are basically small internet-connected modules that have some basic sensor, and they are preloaded with code that allow a maker or kid in our workshop to easily build a prototype out of an idea with the card. But this is work in progress, so I recommend you to keep an eye on the website, and when we release both the software and the hardware for you to use, we will provide more information about how to actually, what's at least the paths, the process to get a physical prototype of out of an idea developed with the cards. So that's all. I'm happy to take questions. I know it's quite late and everyone wants to leave, but if there's any questions, or otherwise, yeah, that's a few links to my email. And any questions? Yeah. Yeah. Yeah, no, not in the same workshop. So we run, yeah. Well, this morning we ran it with basically a mix of makers and teachers and entrepreneurs here at the maker. Yeah. So we used both in school and in commercial project for basically IoT consultancy to come up with ideas for organization and corporation. Thank you. Anyone else? Okay. Thank you. Thank you for coming.